Hi, in this tutorial we're going to do a static pressure simulation of our nitrous oxide tank in Solidworks. The first thing that we want to do, because of the fact that we have debossed text in our part, is we want to come over here to our feature manager tree and we want to take the end of part and move it above our text. So now you see that our debossed text has disappeared. With this being done, we can access our simulation tab. If you don't see your simulation tab up here, you can right click and select it from the drop down menu. If you don't see it in your drop down menu, then you can come over here to this arrow, which says options, click on it and click on add-ins. You can then select the simulation from that box. Let's come down here to this arrow and click on New Study. We're going to make sure that static is selected under type. That should be the first thing, and we're going to hit OK. And from here, SolidWorks gives us a menu of different options. And the first thing that we want to do is have our correct material applied for our part. So I'm going to come over here and right click, and I can select a material from right here, or I can click on Edit Material, and I can select one of the thousands of materials that SolidWorks has to offer. So we're going to leave it at 6061 alloy, and I'm going to hit close. And now that we have our material selected, I can come over to Fixtures, and I'm going to right click here where it says Fixtures, and I'm going to click on Fix Geometry. And from here, I'm going to select this bottom face as well as this fillet. And what I'm doing right now is I'm selecting the faces of our part that we want to have solidified. We want it to be fixed. You can even see in the preview that this green face does not move within the simulation. Now all the other faces and the rest of the body can move, but this is the part that can't. So we're going to hit OK. And this is going to be sure that our part doesn't fly all over the place when we apply a load to it. Now that that's finished, we can come over and right click on Mesh, because we now want to mesh our part. So I can come and click on Create Mesh. And what we have here is our tank, which we want to do a simulation on. And we're going to leave it the way it is. Now, if you'd like, you can create a split, and you can only do a simulation on part of your assembly. So we're going to try that in this lesson. I'm going to click out of mesh because I don't want to do a mesh on the entire part. I only want to do a mesh on a body of the part. So what we want to do is we want to come here to Features, and I'm going to select the top plane from our feature manager tree of our part, and I can come over to Reference Geometry and create a plane, and that plane is going to be 15¼ inches from that top plane. So hit OK. And at this point, I can create a split. So I'm going to come over to Insert, Features, Split, and I'm going to just select Cut the Part because there's only one part currently. And if I select both of these, I can create a split by hitting OK. And so now, if you come to our part, you can click and see that there are two solid bodies. Now that's going to be very helpful to us. And the reason is because if I don't want to do a simulation that includes this thread, maybe I don't want that to be part of my simulation either because it's going to take a longer time for the computer to process the mesh, or because I don't care about the pressure on this particular part of my tank, I can just set it outside of my simulation. And we can do that by right-clicking Mesh, and we can click on Apply Mesh Control. And because of the fact that I have two bodies, I can come down and click on my feature manager tree and select the body that I want to do the simulation on. See, there are two here. I only want to select this body. I'm not going to select this body as well. So we only have one body selected in here. Solidworks gives us a lot of options for working with our mesh within this feature manager. And what we can do here is dial up or dial down the mesh density. Now when I move this slider, Solidworks is giving me a preview of the element size. You can see it come up in this window. If I move this slider all the way to the top, you see the element size is 0.13. If I slide it all the way down towards the coarse side, you see it changes to 0.54. Now the smaller that number, the smaller the element. The smaller the element, the more accurate our mesh. And the more accurate our mesh, the longer it will take to do our simulation study. It'll take the computer longer. So what we want to do is we want to dial down our element size to be as small as possible without being so small that it takes forever to run. So I'm going to set this parameter to be 0.1, and I can type that right into this box in case my mesh density doesn't go down to that number, and in this case it does not. So I'm going to come over here and type in 0.1. And under the ratio, I'm going to leave it at 1. And in case you're wondering what the ratio is, it's the largest dimension of your element divided by the smallest dimension of your element. The elements are what make up the shape. They are the tiny building blocks, the tiny 3D tetrahedral building blocks of our mesh. So we're not going to delve too deeply into that in this video, but that's the basic idea, is it's the largest dimension of one of these elements divided by the smallest dimension of that same element. And so the larger this number, the more skewed and longer that element can be in one direction. So we're going to leave it at this, and we're going to hit Create Mesh. And I'm going to hit yes, and you're going to see that it's creating a mesh really only on this body, the one that we selected. And so one thing to remember, which we spoke about, is that the smaller the element, the longer this is going to take. It's also going to take you longer once we get to our actual loading analysis. And so with that completed, you could see that we have a very fine mesh, which is great for our simulation. Now, it doesn't need to be this small. This is actually very accurate, almost maybe even too much information depending on what you're going for in terms of accuracy. But because of the fact that we're using a computer that can handle this type of simulation, we're actually going to leave it like this. Now, the size of your element will partly depend on that. If you have a very powerful computer, then you can afford to go for elements that are this small. If you don't, then you may need to settle for a larger mesh. That being said, we can right-click on external loads and come down to pressure. But first, I want to look at this part in half because we want to select the inside walls of our tank. So I'm going to click on the section view, and I'm going to hit OK. And now I'm going to right-click on external loads and hit pressure. And you're going to see that we have our half view. And what I'm going to do is I'm going to select these inner faces. And so I'm going to select these two faces and the face here at the bottom and this fillet. And with those selected, I can come down to my pressure value and select PSI, which is what we want to use. And in this case, because this is an H tank of nitrous oxide, I'm going to set the PSI to 2200. And so we're going to hit OK. We're not going to select non-uniform distribution or anything else for right now. One fun fact is you can change the size of the arrow. Now, that's really just going to change the way that it's displayed. So we're going to hit OK. And now we have our pressure defined. We can now run our simulation. Let's come up to the Simulation tab, and let's click on where it says Run this study. Now, I've already run my study because of the fact that it takes a very long time to do so. Once you run your study, you'll have this Results tab come up, and it will have your stress, your displacement, and your strain. I'm going to click on Stress, right-click, and I'm going to click on Show. And it's going to take a little bit of time to load. And once it loads, you're going to get the simulation result. Now, as you can see, this really isn't helpful because of the scale of the part. So I'm going to right-click and hit Edit Definition. And once this comes up, I can change my display of our deformed shape to be a user-defined. So basically what this means is Solidworks has created this simulation, and the result that it's giving me is, you could actually see it here, 36 times the size that this vessel would get larger. So in real life, I'm going to click on user defined, it's actually just 1. It's a scale factor of 1. That's the 1-to-1 scale of the simulation. So I'm going to change this to PSI because those are the units that we want to use. And I'm going to hit OK. And doing this is going to give us a much more accurate representation of what the part will look like under these stresses. This is a 1-to-1 analysis of the stress formed along our part. So as you can see, different sections involve different amounts of PSI stress. Now I can actually change this to displacement here, and I can right-click and hit Show. And that's also going to be in the wrong scale, so I can edit the definition and change this to true scale or user-defined. And once this loads, this is going to give us a very accurate representation here of our part. And as you can see, the bottom of our part is where there's little displacement, and then over the middle and top is where there's a lot more displacement. So the highest area seems to be right over here in the middle. That seems to be where the most pressure is. And so what we can do is we can right-click and hit Animate. And what Solidworks is going to do is it's going to animate the stress as it propagates along the part walls. So you could see it's creating the different frames. And it gives us this sort of this GIF animation, and I can dial down the speed. And you can see the stress propagating, and you can see that the most amount of stress basically comes here in the middle. So that's going to be very helpful to us when we're designing. We can see here that at the bottom there's little stress, likely because of the geometry of this curve. Now, if the geometry was different on this middle section here where the cylindrical part is, then of course we're going to have a different plot. And that's mostly what simulation is about. It's about testing your geometry to see what works and what doesn't, and what exhibits either the most or least amount of pressure. So we're just going to hit cancel. And we're going to look at strain before we're finished. So I'm going to show this analysis. And on the right side, we always get a plot of what's being shown. So I'm going to edit the definition again. And we're just going to hit true scale. And we're going to hit OK. And you can see that it gives us a very similar plot here. Now there are a couple of things that we can tweak. Now if I come back to my display, I can change this to the strain in one particular direction. You can change it to be maybe just in the X direction. And the frame of reference is, of course, your triad right here with your X, Y, and Z. One last thing that I want to show in this tutorial, which I find to be very helpful, is the use of a cutaway cross-section to look inside of your part geometry. So I'm going to double click on this stress 1 just to reactivate it. And I can right click and come to section clipping. And with that being done, I can create a section of my mesh in order to look at the stresses that are going on inside of my model. Now before we were looking on the outside and we saw that the stress on the outside looks one way, but on the inside it looks much different. And if you're designing an H-tank for pressure with 2200 psi, it definitely pays to look inside the part to see what's going on. And so this is very helpful. The other helpful aspect of this is you can come and change the distance here. And doing so is going to let you see different cross sections of your part. So I can come over and zoom in on a certain section here, and I can see how the pressure changes between the curved area and the straight area.